Hello everyone. This is the presentation of Group 6th, which is given by the students Khushi, Jiya.Khushi, and Kamna. The topic of our presentation is phenol formaldehyde resins. So, phenol formaldehyde resin are a polymeric product which is obtained by condensation polymerization of phenol and formaldehyde. Now, what is condensation polymerization? In this process, the two monomers come together and they condense means club together to form a linkage which gives a byproduct. The raw materials used in this process are phenol, resinol, and formaldehyde. Phenolic resin is heat cured plastic formed from a reaction of carbon based alcohol and a chemical called aldehyde. Now, what is heat cured plastic and why they are termed as such? This is because they undergo a curing or hardening process when exposed to heat. The curing process involves cross linking of phenolic molecules, forming a 3D network which makes them as such. Formaldehyde is a common raw material for this type of resin. The resin is hard, heat resistant, and can be mixed with range of materials for industrial and residual uses. Phenol formaldehyde resin is a thermosetting polymer, means it is a type of polymer that once molded into a particular shape undergoes a permanent chemical reaction which cannot be reversed and hence cannot be reshaped into its original shape. Phenol formaldehyde is used as the basis for bakelite. Now, coming on to the history of phenolic resin, it was first produced by polycondensation of phenol with aldehyde in the year 1860. In 1860, von Baer first reports the reaction between phenol and aldehyde. The phenolic resin for condensation was used industrially in the year 1902 by Blummer for production of Novolac. Now, coming on to the history of bakelite. Bakelite was the first made by Leo Baekeland in the year 1907. Phenol formaldehyde resin, commonly known as bakelite, was the first synthetic plastic ever created. In the year 1907, Leo Baekeland successfully synthesized bakelite while he was finding a replacement for shellac, which is a natural resin used in electrical insulators. Bakelite was first used to make billiard bulbs, but later was used to make molded insulation valve parts, knobs, buttons, knife handles, radio and electrical instruments, and many more. Properties of bakelite. The physical properties of bakelite include color, density, transparency, and electrical insulation. Bakelite is typically brown, but it can be produced in various other colors, and the various other colors are also shown in the image given along. The density of bakelite is relatively high, making it heavy and solid. It is usually opaque and non transparent. Bakelite is an electrical insulator which makes it suitable for various electrical applications. Coming on to the thermal properties, it includes melting point and resistance. Bakelite does not have a sharp melting point since it is a thermosetting plastic. Instead, it softens and decomposes when heated. It can withstand high temperatures without softening or melting. Flow properties include non-thermoplastic. Unlike thermoplastic materials, bakelite does not soften when heated and cannot be molded again after it has been set. Mechanical properties include hardness, strength, and brittleness. Bakelite is a very hard and rigid material. It has good mechanical strength, making it suitable for use in industrial applications. Bakelite can be brittle and prone to shattering under heavy impact. Applications of bakelite include electrical insulators, jewelry, radio and telephone casings, kitchenware, automotive parts. Bakelite is extensively used for making electrical insulators, sockets, circuit breakers, and switches. It is popularly known for making colorful and stylish jewelry. Bakelite is used for casings of radios and telephone, providing durability to them. It was used to make kitchen utensils and handles of pots and pans. It was also used in the automotive industry for making parts for like distributor caps, brake pads, and steering wheel due to its heat and impact resistance. Now, coming on to the second phenolic resin, it is termed as Novolac. Novolac is a type of phenolic resin that is created by partially reacting phenol with formaldehyde. Unlike Bakelite, Novolac resins are not fully cured during their production. These are the resins which are produced by complete polycondensation of phenol in aldehydes for industrial uses as a replacement of natural resin such as shellac. It is available in solid and liquid form and is used in binders, articles, paints, molded pieces, laminated plastics, and adhesives. Physical properties of Novolac include density, color, hardness, and brittleness. These polymers have a typically high density, which contributes to their durability and resistance to wear and abrasion. They can be transparent or opaque depending on the specific formulation and additives used. They are known for their hardness, which makes them suitable for application requiring rigid materials. These polymers can be brittle, which can limit their use in certain applications. Coming on to the thermal properties of Novolac include melting point, thermal conductivity, and thermal expansion. These polymers do not melt when undergo a cross-linking process. Instead, when exposed to heat, it makes them thermosetting. Thermal conductivity, these polymers generally have low thermal conductivity, which makes them suitable for insulating applications. They have a low coefficient of thermal expansion, which means they do not expand or contract significantly with changes in temperature. Flow properties of Novolac include these are typically not designed for flow. Unlike thermoplastic polymers, they do not soften when heated and cannot be reshaped once they have undergone the curing process. Mechanical properties of Novolac include strength, stiffness, impact resistance, and chemical resistance. These polymers exhibit high compressive strength and can withstand heavy loads. They are stiff materials and have a high modulus of elasticity. These polymers can be brittle and may have low impact resistance compared to some other polymers. They often show good resistance to a wide range of chemicals and solvents due to their cross linked structure. Applications of Novolac include adhesives, coatings, abrasives, fire resistance material, oil and gas industry. Novolac based adhesives are used in application where high temperature resistance and chemical resistance are required. These coatings are applied in various industries to protect surfaces from corrosion and chemical exposure. These polymers can be used as abrasives due to their hardness and wear resistance. These polymers are used in manufacturing of fire resistant materials such as fire resistant coatings and fireproof fabrics. Novolac based materials are used in the oil and gas sector for application like downhole tools, coatings, and insulating components in high temperature environment. With this, I conclude. Thank you and have a nice day.